Welcome everyone. I want to talk today about the new features in Dart-free patterns and records actually. I'm Pascal. I'm the co-founder of Phantom, which is an agency in Germany. We do Flutter only. And I'm also the co-founder of Wiredash, which is a cool feedback SDK. So if you have a Flutter application and you want your users to give you feedback in a nice way, please include Wiredash into your application. And yeah, you will love it, trust me. All right, today I want to talk about records and patterns. But before we talk about the new language features, we want to check what language features are, where they are created, and how you can request them. There's this repository, it's a language repository in the Dart organization. And it exists for like 3 years, actually more, 5. And we overall have over 3,000 requests for new language features so far, and 1,000 of them are still open. So of course, there were some duplicates, some not so cool ideas, of course, but we have over 1,000 ideas how to improve the language. So the question is, how do we select them, which will be implemented next? By votes. So these are the most voted features that we requested. And I quickly want to show you what has already been implemented. So it's always sorted by votes, and the Dart team goes over them and sees which is the highly voted feature, and then they will eventually build this. What they did in the past is, of course, we had like extension methods and like enums with members, features like that. But in the latest iteration in Dart 3, we got a ton of our mostly requested features finally implemented or partially covered. Records and patterns together cover here like 7 of the highly requested features, and I want to quickly show you what they are all about. So with the records feature, we got kind of data classes, which is the #1 requested feature, multiple return values, and destructuring. And with patterns, we got pattern matching, of course, but also ADTs, union types, sum types, and things like that, as well as like the new switch expression, which also was recently introduced into the JDK 12, and we now have an equivalent in Dart. So I will show you today what are records, what are patterns, and how we can use them, and what are the pitfalls. Let's start with the first one, records. This is a simple record, a record of 2 numbers. These are ordered by position, so we have a first value and a second value. But we can also make them named so that we have an X and Y value and assign them 2 things. In other languages, those records are called tuples, but it's not a right fit here in Dart because tuples are by default only by positional, and records also have named parameters, and so record is quite a good fit. If we look at a more complex record, so this is a record that has both positional and named arguments. So 2 strings as positional and 2 named arguments as A and B. You can access the fields by position with $1, $2, or by name. And now let's look at the type. What is the actual type of such a record? The type looks like this. So for a positional one, it's just like the parentheses and then the 2 types. And for the named ones, you use the parentheses. And you are quite used to that syntax because it's also the one that you use with functions. For the positional ones, you can add names to the parameters, but they only have a documentational purpose. They have no other value. As I already told you, it looks the same. So the parameters of a function looks like the record parameters. But there's one difference. So you might think, oh, this is the same, but actually this code does not compile because, of course, we are missing the required keyword for the position ones in the function. There's no required keyword for a record. By default, all parameters are required. And you also have to assign all of them if they are required. And this looks like this. So even if fields are null, you have to define them. Even for named arguments, you cannot leave them empty. You have to define them. That's the thing about a record. Types, again, look quite similar to what you see in functions definitions. If you have such a quite complex record, you eventually want to type def it. So you don't have to do this, but at some point it makes sense, especially if you pass things around because you want to put it inside other functions and pass it around and make it type safe. You don't want to repeat yourself. Eventually, you're still in development. You want to change some things. Type deafing is a good thing. And it behaves like any other object. So no difference there. Let's look what is basically compiled under the hood. This source code here you see from the My Complex record is not a source code you can see anywhere. It's inside of the compiler, but it just gives you an idea what the compiler actually generates for you if you use the record feature. First of all, it extends a record. Record is a new class, and it's only for code generation, so that when we as a code generator see, oh, this is of type record, we know how to treat it, whereas you as a normal developer would never use that type record. But it's nice to know that the record type exists. The fields are generated there with $1, $2. It's starting at 1, not 0. And then, of course, there are the named argument and a cool toString function. What's now very interesting is that a record by default also generates an equal operator and the hashcode implementation. So by default, it uses all the arguments that you put in and calls equals on them if you use equals on the record itself. So how does this look like? I have two examples here. I created an issue with one string, one int. We know how that works. You can call equals on that. And also an empty list. Empty list, that's something I know. It has a hash code of 1 and can compare it to itself via equals. That's easy. But what if I change that? So if we are not only seeing like an empty list, but if we put actual values inside. And then it looks like this. If you put values inside, all of you should know that a normal Dart list does not implement the equals. So you have to use like list equality or deep equality to get the equal sign work. And this gives you false if you compare those two records, although we know those are actually the same. But they are not. We cannot compare them by equals, and that's something you have to keep in mind. You might want to use a different data structure that actually supports equals. So for example, Katie list here, it's a different list implementation which supports equals, and then suddenly you get true if you compare those two records. That's something you have to keep in mind. There are other cases, for example, if you put a function reference inside, functions reference are never equal to itself, so this might also break your records, or at least the equal implementation of it. And you also have to know that you cannot override the equals implementation of your record. You have to use what's there, and you're limited to that. Records by default are immutable, which is a huge win, especially if you're coming from functional programming. One downside is that they are immutable because sometimes you want to change a value. The only way you can do this is by creating a copy, and unfortunately, we don't have a cool copy with function we know from other types. So for example, with freezed, the code generator freezed for immutable data structures, you can use copy with there. And if you have to use this often, I will still recommend you to use freezed instead, because freezed does not only generate the copy with method for you, but also it has a copy with method for deeply nested objects, which makes it very handy to change single values down of an immutable object. There are issues for this, of course, in the language repository to add this, but they explicitly did not add this right now. Maybe it's coming in the future. Maybe it's also coming if they are really implementing the data classes, because this issue is not resolved. Records are fine, and some people would use a record where they would actually use a data class in other languages, but data classes still have their own purpose, and copy with is one reason why this issue of data classes is not yet finished. So it's still our #1 upvoted feature, and you can still upvote for it, of course. Let's talk about the form of a record, because this is the interesting aspect of it. This is a small library I created. I called it geometry. That's something we learned at school. A point has like 2 values, x and y, and if we have 2 points, we can make a line. If we have 3 points, we can make a triangle. We all learned that in school. We can create extensions for these types. So for example, the length of a line or the area of a triangle. Easy, isn't it? It now gets interesting because, of course, we can call this. The syntax might look a bit odd because I'm creating the points here as well, and it's just all in a single line. But you get the idea. We can just use it and create this data structure it detects automatically that this is like 3 points nested at the bottom, and it knows it's a triangle, so we can call the extension function on it. What if I have a different library? So on top we have like the geometry library, but at the bottom I have my 2D game where I defined a coordinate. Also two double values, x and y. The interesting part is you've seen the extension for the length, and we can also use the same extension for our coordinate. So in my 2D game, although I never share any code with the geometry library, I could also calculate the length of my line, which here is like 2 coordinates. And this is pretty powerful because now multiple libraries basically can share code with each other without actually depending on each other. And that could be really powerful in the future. I think there are no libraries out there that do this yet, but we could definitely use this in the future. Just to repeat this again, they have the same form because they have the same number of arguments, they have the same name. So this is the form, they have the same type. And because they have the same type, we can use the getter from the one library also in the other library. Yeah, and packages now can share different APIs. For example, one favorite or one library which could be useful is the lat-lang library, where we have latitude and longitude in a single data structure, and there might be different packages that might make any calculations with it. In the past, and some people might know this, some people not, in the past, like 2017, we had a class in Flutter called point. And it was eventually removed because point and offset are super similar. They only have like an x and y value. So what's the purpose of keeping both implementations? It's the same thing. I would say they are not the same thing. I always find it weird when I have to use an offset to paint something in space. It would make more sense in that case to use a point, just from a semantical point of view. And it was removed, but if we would have records in the past, like in 2017, probably neither offset nor point were in the Flutter SDK, but instead we would just use a record of an x and y value, and we could name it however we like in our space where we're using it, while still maintaining all the flexibility of using the multiply operator, for example. This might work in any case. Let's talk about the next big feature, which is destructuring. So far we created records, we accessed the fields, but there might be an easier way to access the fields with destructuring. So if we create here a line of course is like 2 points, we can access the x and y value from the first point in this case. Easy. But we can also destructure it in this way. So why not assign 2 points directly into 2 variables and access the x and y values from that? We can do this. And this is destructuring. We can shorten this a bit because we don't have to tell the compiler the type point. Instead, we can just remove it. So remove the points here, and the compiler already knows, yeah, those are 2 points. We can assign it to variables a and b. This looks complex, but this is like the full version of destructuring. Like the first one, we are not destructuring. Then we destructure the line, and then we are destructuring also the 2 points in each line, and we can access like the values of that deeply nested values. Doesn't look nice, but theoretically this is possible. Of course, you want to use the short version for this, so it looks like this. For the first one, you just assign a and b, access those 2 points, and if you really want to access like the x value of the first point, you can assign a new variable here. So from the first point, we assign the x value to the new variable called ax. And for the other ones, I just use the placeholder because I don't care at that point about them. There's even a shorter version for this. So if we have a point here, x and y, we can already assign it to x and y values if we use the same name for the variable. So if the record has an x value and we wanted to assign it to a local variable called x, we can use the colon x and colon y. I personally have never seen anyone using it, to be honest. But it's possible and it's quite short. We can use the same for name parameters. It's just the same thing. We have to match the name X and Y. So, quick question into the crowd. Who is maintaining a package on pubdev? See some hands? This is really important for you, because what about breaking changes? This is like a function serializing a double into a Matissa and exponent, and you might ship this inside of your library. That's okay, but you are not allowed to change anything of that record, because it's now part of your public API. And if you change anything, it will be a breaking change. So the things that you cannot change is the type. Whenever you change the type, someone might have destructured it and used the type. If you change the type, you cannot. It is a breaking change. You cannot change other people's code. You are also not allowed to change the name of your arguments, at least for named arguments. This is also a breaking change, because people might assign it directly to the local variable of that name. You cannot change that. And this is quite interesting. You are not allowed to add new parameters. With a class, you can always add new parameters, and it is not a breaking change. But this is not true for a record. You are not allowed to add new arguments, because someone might destructure it, and they destructure it just to 2 variables. If you add a third one, their code breaks. So be very, very careful if you use records, and especially be careful if you use records in your public API. Quiz time. You don't have to answer this, but maybe answer it in your head, because this is also interesting. Let's talk about records with just a single element in them. Which one compiles, which one is correct? What's the output of those 2 lines? So what is the runtime type of 1 and what is the runtime type of 2? Think about this in your head, and I will show you the answer right now. The first one, of course, is just an integer, because parentheses mean nothing. They can just be removed. At the bottom one, we have this comma, and the comma tells us this is a record and not just parentheses around an integer. So the bottom one is a record, the top one is just a plain integer. The same is true for the type. You cannot define a type like this. You have to add the comma for a single element. So quite interesting. You don't have to add a comma at the end if you have multiple elements. Then it's fine. The compiler can detect the difference. But for a single element, you have to add it. I don't think anyone here will use a record with a single element, but theoretically it's possible, and it's quite funny. Let's talk about something I found interesting, and that is like the future wait call. I think many of us use this already. If you want to have 2 future, calculate something in parallel and then give you both results back. In the past, we had to call future wait. We get a list of dynamics back, and then we access it by index, and we have to cast it manually. This is now gone, and I overlooked this when I first gave this talk like half a year ago. There's a new function in the Dart SDK we can use. It's an extension function. I think it's one of the first extension functions that made it ever into the Dart SDK. And it's the wait extension functions. So in the future, you can just wrap your futures in parentheses and call .wait on it, and you will get a record out of it, a type-safe record. You can destructure it right away, and you have both values. Pretty cool, isn't it? I overlooked this. I wrote those functions actually myself until I discovered that there is an extension function for, I think, for up to 9 futures. If you have more, you have to do it yourself. Destructuring of records is fine, but what about other objects? Yes, we can destructure now everything. This is not limited to records, but also to, for example, lists. So if we have any list, but you only want to have the first element of that list assigned to a variable, you can use the spread operator here to skip the rest and only assign the first element to your variable. The same works for the last. You can add the spread operator in the middle and get the first and last element. But you have to be very careful. What about 2 elements? So you want to have the first and the second element. But what if you only get a list of like 1 element? That's actually a runtime error. So no compiler will warn you about that. You have to know it for yourself. Oh, I'm pretty sure that I get a list of at least 2 elements. If you get less, like 1 or 0, you will get a runtime error. And until now, the error is not very descriptive. It just shows you a pattern matching error, and you have to figure out yourself what's wrong. Yeah, keep in mind, always handle like all the cases. You can also destructure maps. Maps destructuring is pretty cool because you can actually skip values that you're not interested in. You don't have to use the spread operator. You can just define the values that you want. Here, I want to get the value of key A and assign it to my variable value, and I can print it. I thought when I first read the proposal for this thing, what about sets? It would be cool if we can destructure sets. Yeah, nice idea, it doesn't work. Sets by default are unordered. We cannot access the values by index. They also have no name, so we cannot access the values by name, so it doesn't work. There's no way to access this. This also means we cannot destructure a set. Okay. The biggest change is that we can also destructure objects. Like any object you already have in your code, we can destructure it. Here I created a burger. You see the class at the bottom, but it really doesn't matter what the class is about. And we can, instead of assigning burger to a variable and then access the name, we can directly access burger name. Or if we use the shorthand, if we just want to assign it to a variable called name, we can use colon name and we can access name directly. You cannot access the burger in this case, but you can access variables inside that burger. And this works for all classes you already have in your code. Sometimes I do other things than Flutter, and I look over to the JavaScript world. It's pretty interesting there, and this is a common pattern you see in React, for example. You create a useState, and sometimes you only want to access the value, the count. Sometimes you want to also access the setter, setCount. This is completely fine syntax in JavaScript, and I thought, oh, how can we do this with destructuring in Dart? Let's see. If we would use a list, we have to use the spread operator in the end. We cannot skip any value. Remy already created an issue for this, so this might be changed in the future, but as of now with Dart 3.2, it is still there. We have to use the spread operator to skip values. What about a record? I talked about records, they are nice. Same thing, you either have to use the spread operator or the underscore, and in this case I use the underscore because I don't care about this value, but I have to add the underscore. Not that nice. Just saw what about destructuring a class or any object. Created an object called state, and here we actually can destructure only the count and not the setter if we want, but we have to wrap it inside of our state class. This might also be removed in the future. There's another issue open that we might not have to state here. Let's see if that's changed in the future. Either way, we are not there yet. We cannot replicate the same syntax as we have in JavaScript. Leaving records and destructuring aside, let's go to our next topic, pattern matching. This is a small code I have. We saw our burger so far, and I want to have a switch case and print the correct burger depending on our burger type. This is something you see in your code already, and this is like pre-Dart 3 code. Since Dart 3, we can change the switch syntax of our switch case here because we can remove the break. This is new. This was always redundant, and we can just remove it. Our code is the same. It works just fine. So please go through your code right now and remove all the breaks. Not required anymore. You should probably already seen it once you upgrade to Dart 3 because your linter might have said to you, just remove it. What else can we do? I personally think that it would be great if we can add other patterns here. And this is new. In the past, if you had multiple patterns, you have to write them one by one in each line. Now you can write them in the same line and connect them with logical operations. So in the past, you were only able to add an AND. Now you are also able to add an OR something like that. What about these burgers? The variable burger is mentioned here 3 times. It's not a good style in my point, because if you ever change the name, you have to change in every line. I personally, in that case, always use the immediately invoked function expression. Nothing new. I think this exists since Dart 1 or earlier. And I use this all the time because now I can just write return instead of writing burger equals everywhere. And I use return here. Yes. So now we switch to the new switch. There's a new switch expression in Dart3, which is alongside our switch case. So those are two language features, and we can use both depending on what we like. This is the switch expression. It is much shorter, and I want to show you in detail what's the difference. So those are those two things, the switch expression and the switch case, and we can play a small game here because there are 8 differences and we have to find all of them. So check the code and see those 8 differences, because those are the differences that you actually have to change if you switch from the one to the other. Because you save 3 lines of code, so you also want to go through your code and update all the old switch statements to the new one. So you have to update it. There's no automatic updater yet. You have to go through it yourself. Okay, who has found 8? Let's see them one by one, because they are quite interesting. First, the switch expression has a return type. This is completely new. So far, switch had no return type. We had to use the immediately invoked function expression. Now it has a return type. But it's worse than you think, because it requires a return type. Actually, it is not a valid code if you write the switch expression, the switch keyword at the beginning of the line. This is not valid Dart code. There has to be something in front, like a variable assignment or like parentheses. Yeah. What about the rest? We have no case anymore. This is also why it's not called switch case. It's called switch expression. There's no case. We can use the arrow functions. But we also have to manually go in there and exchange every case with an arrow. We don't have columns anymore and use the arrow there. So the case was just removed. The columns are now arrows. Something else you have to change. What else? Default is not allowed anymore. You have to use the underscore. Different syntax here. What else? You have to exchange commas with semicolons and vice versa if you switch between them. Bit annoying, but that's how it goes. And you don't want to forget the semicolon at the end. You didn't require that beforehand. What about multi-lines? In the past, you could write multiple statements in your cases. This is not allowed anymore. It's just one statement or one expression. If you want to have multiple lines in your cases, you have to use the immediately invoked function. That's why I showed it to you earlier. You still have to use it. There's no way around it. So there are quite a few differences between a switch expression and a switch case, and you really have to be careful if you switch between them. Those two switch cases, they have a bit of a more problem. So it's a different syntax, yeah, but maybe eventually there's tooling to convert between them. They have different features, so some have the return value, some has multi-line support, the other doesn't. So you have to be careful with that. And yeah, it's hard to migrate them. I always hate when I do pair programming with a junior and tell them, use a switch expression here instead of the switch case, and then I have to go through them. You have to use exchange the semicolon with a comma and vice versa. It's a lot of work. I hope there's tooling there. But there's one other thing that really annoys me, and we could have a different name for this because they look similar, but they are under the hood not very similar. Why not have like a match name and not switch? And the main reason for this is because we all use code generators like AI code generators these days. And trust me, GitHub Copilot has a hard time to see the difference between them. These days, if you create a switch expression in GitHub Copilot, sometimes it gives you the switch expression, sometimes a switch case, sometimes a mix which doesn't compile at all. It's really hard for LLMs to see the difference and can generate new code that is correct. Okay, but the switch expression is actually kind of cool because it allows us to have pattern matching, and I will show you some cool examples about pattern matching. So first of all, we have patterns here for file types, and not only file types, but we can also extract variables of those types. Pretty cool. We can even go further and access those variables in the when clause. So we now have guarding inside our switch expressions, which is very, very powerful, but maybe just me, I have never seen anyone using them in the wild. So I personally would still write this code. It is simpler, but yeah, it's most likely also easier to debug. I'm not even sure if you can set a breakpoint inside of this when guard clause. Last thing is the sealed classes. And for sealed classes, you can, for example, I have this login, and my login result is a sealed class. Sealed class means I have this class which I seal so that I know the number of instances that exists. For my login for my login result, it might be a success. It might be one of those known error cases that I created. The cool thing about this, because switch expressions are exhaustive, this means the compiler knows you caught all the possible cases, and you can remove the case that is the default, because the compiler knows everything is cached. Sealed classes are amazing. I definitely will use them, but if you are writing a package, you probably want to use them, but if you are writing like your own source code, you might want to use freezed instead, because it's, again, just me, I like the syntax of freezed a bit more. It's shorter, but yeah, you have to add an extra dependency with code generation. Maybe not worth it. If case, the same thing with pattern matching, not with a switch expression, but you can also use it with an if, and that's something you have to get familiar with. The if case, who has seen it before? Yeah, you will see it all over the place in the future, and it looks odd. To those that never seen it, what does it do? I don't know. I couldn't understand it when I first saw it. So the actual code is like, I check for the length of 1. I want a list of like length 1, and I assign the first thing to a variable called card. And then it looks like this. It checks for the pattern, a list with one single element, and I assign this one element to card. Okay, that's something we have to use in the future, and of course you can use the guard clause here as well. And matrix matching is the final step. It's when you have a set of booleans, a lot of booleans, and you want to make sure that you handle all the different cases. It's quite easy with 2. It's a bit more complex with 3. With 4, it gets even more complex. What you can do, you can create a record. Now we are mixing all the things. We can create a record of all the boolean parameters and put it inside a switch expression. And then the compiler can tell us, is our code really catching all the cases? And if it doesn't catch all the cases, it tells us exactly, oh, you forgot the case where the first one is true, the second one is false, and the third one is something else. You forgot this, please handle this. Honest questions, who is scared about these new features? It's quite a lot of code, quite a lot of changes, and the question is it really worth it? I don't know, but it's there and we have to use it. We also have to get used to it because, yeah, it's out there. Other people use it, we have to read it. Those features are all covered. What about the rest? What's open? What are the most upvoted features right now? It's still data classes on top. We have static meta programming, which might be very cool in the future, where you have macros that run at compile time to generate code in the background, basically code generation at compile time. Optional semicolons will not land. Compiling with semicolons is faster. We don't want to have our fast compiler getting slower, so not happening. Static extension methods, like for any type, add a static extension. That's quite easy. Or a shorter enum syntax, that's also highly requested. Things like that might come in the future, and eventually at the bottom some types, because although we have records and we have all the other features, sometimes it's still not possible yet. What is our mission right now? We have to go to the language repository of Dart and upvote for your favorite feature, because the Dart team is listening, and whatever is upvoted most, they will look into if they can implement it quite fast. We can explore patterns and records and get used to the syntax. We don't have to use them, but we have to get familiar with reading them. And please create issues. Whenever you have an issue and don't understand something, create an issue, because other people will ask the same question, and they will happily upvote your question. And also, like ChatGPT is probably also reading Stack Overflow, so put it there. We don't have best practices yet, but we are working on that. So while we are thinking about how to structure our code better, we might come up with best practices, and they will eventually end up in effective Dart, but not yet, because those features are new. Please, please, please don't overuse those features. I know they are new, they are exciting, and we want to use them, but trust me, code before was quite readable. Yeah, don't overuse them. Thank you very much.